Hello, and welcome to another episode of A Conversation with Carl. Remember to like, follow, and subscribe for the latest content. Today, I am privileged to speak with Dr. Ronald Lawrence Mallett, a physicist, academic, and author. He is currently Professor Emeritus at the University of Connecticut, where he has been a faculty member since 1975 and is best known for his position on the possibility of time travel. He is also the author of, I'll just make sure I get the book in there, Time Traveler. Please welcome Dr. Ronald Lawrence Mallett to the conversation. So, thank you so much for joining me today. The story of what led you to pursue this career path is incredibly moving. Can you share that with us?
Sure, I'd be happy to. It actually was started in New York City. I grew up in the Bronx, and my father was a television repairman, and he was very, very good at his job. I mean, he was, when I say he actually repaired the television set of actors and stars that were in New York at the time. And I thought of him as a television repairman to the stars. And I was the older of four children, and I idolized him. For me, the sun rose and set on him. The day just wasn't right until he came home from work. He looked very healthy. He looked robust. The thing is that we didn't know as children, we didn't know that he had a weak heart. And the thing is he died of a massive heart attack when he was only 33 years old. And I was 10 at the time. And I was devastated to say that I went from being a happy kid to being a really depressed kid. He left me with a lot of toys. I mean, when I was growing up, he would show me things like a gyroscope, crystal radio set, and he also loved to read, and I loved to read. And that saved me because about a year after he died, I came across the book that changed my life. It was actually a Classics Illustrated version. It was called The Time Machine. And the thing is that inside it said scientific people know very well that time is just a kind of space, and we can move forward and backward in time just as we can in space. And I thought, this is incredible. If we can move forward and backward in time, then this means that I could go back into the past and maybe see him again and save his life. So that actually became an obsession for me, was the notion of trying to build a time machine. And my mother had kept his television and radio parts, and I tried to cobble something together with bicycle parts and everything, and plugged it in. Nothing happened, which is probably just as well. Probably would have burned the house down. But the thing is that I was disappointed, but not completely discouraged, because I remember it said scientific people know. And so I knew science was going to have to play some role, but I didn't know exactly how. But I was sort of a bookaholic. That is to say, I really rather read than eat. And I should mention that after my father died, we had been doing pretty well. But after he died, we actually plunged into poverty. I don't know how my mother did it. She was only 30 years old with four kids, and I was the oldest of those. And the thing is that even though she had a high school education, she was only able to get jobs as a maid, things like that. But she kept things together. The GI Bill helped that a little bit too. The thing is that I could go to the Salvation Army bookstore, and for a nickel, I could get books. And then when I was about 12, I came across the second book that changed my life. It was paperback, and it had a picture of Einstein on it. Now, I didn't know what Einstein did, but I knew he was this great genius. And in fact, what was interesting is that Einstein died in exactly the same year my father died, 1955. In fact, they died within a month of each other. The thing is that it had Einstein on the cover of the book. It had Einstein standing next to an hourglass. So I thought, well, this great genius must have something to do with time. So I got it. And even though I didn't have the background to understand it completely, but I got the essence of what it said. It said that unlike the old physics of Newton, where according to Newton, nothing can alter time, but according to Einstein, there are ways you can alter time. And so I picked that up, and I knew that I was going to, if I could master Einstein and understand what Einstein could do with time, then that might help me with the time machine. And so that actually became the beginning for me.
So,
College was out of the picture for me. I should mention that. As I said, we were poor, but I went into the service and I used the GI Bill. This was during the Vietnam War period. To go, eventually, I went to Penn State and I got my bachelor's, master's, and PhD in physics. And that's when I learned about exactly what Einstein said. I should mention that this was in the 50s when he died. And as I said, science fiction wasn't the big thing it is now. There was no Star Trek. We weren't in space and everything like that. So I knew people were already worried about me. So I kept it a secret about wanting to build a time machine because I thought that might not be a good idea. So what I decided was is that there was something that Einstein looked at that was considered to be a crazy idea, but it did affect time, and that had to do with black holes. So that actually became my specialty. That was the way in which I could actually talk about, how time could be affected. So that's sort of a summary.
My next question is that anyone seriously discussing time travel must include Einstein's theory of relativity in the discussion.
Absolutely.
And you've studied Einstein your entire career, and you do a great job at distilling his theory down for lay people like me. So, can you share Einstein's theory and how it relates to time travel?
Sure. Einstein actually developed two theories that he actually developed many more than these two, the theories of relativity. He was actually responsible for ideas associated with quantum theory. But the thing is that his two major ideas had to do with relativity. The first one he developed in 1905. And the essence of it is to say that time is affected by speed. What Einstein meant by that was the faster you move, the more time will slow down. If you're in a fast moving vehicle, time will slow down. It will actually slow down for any speed, but the closer you get to the speed of light, the more dramatic it becomes. And when I talk about time, I'm not just talking about mechanical clocks. Your heart is a clock. Now, you would notice this, but if someone was seeing you zoom down fast enough, I mean, it's like when you're in your car, you don't realize you're going 65 miles an hour, but people see you zooming by. If you were going fast enough, they would actually see your heart rate slow down. Time for you would slow down. You wouldn't feel it, but they would see that happening. Now, you might say, has this ever been
So,
shown?
can I ask you another question? I'm going to
Sure.
interrupt you. So, when I'm on an airplane, does my heart slow down?
Exactly, Carl. When you're on a plane, okay, the thing is that planes are going close to the speed of sound. So that seems to be fast, but compared to the speed of light, sound is practically standing still, but it's happening at any speed. It's just that the faster you move, the more dramatic it happens. And in fact, when you were talking about planes, that's one particular example. People aren't aware of it. But in the 1970s, as a test of Einstein's theory, what they did was to take two atomic clocks. One of the atomic clocks was kept at rest at the Naval Observatory. The other clock was put on an ordinary passenger jet and flown around the world at around the speed of sound. When they brought it back, the atomic clocks are so sensitive that when they brought it back, they actually saw that the atomic clocks had slowed down compared to the clock that had been at rest at the Naval Observatory. That means that the scientists that were on board, their heart rate had slowed down. Now, the reason why this didn't appear in the New York Times and everything is that even though it slowed down, the speed was so small. I mean, the speed compared to the speed of light was so small that the effect was just fractions of a second. I mean, just, you only could see it on atomic clocks. When we have rockets that can go fast enough, close to the speed of light, we'll see the effect dramatically. We'll see it in terms of days and years. In other words, an astronaut that's going out in space, if they're traveling close to the speed of light and traveling to a distant star and back, for them, only a few years will feel like it's passed. But here on the Earth, time will be marching on in its normal way. So decades could be passing here on the Earth. When an astronaut comes back, they may only be a few years older, but time will have passed here on the Earth and decades will have passed. Okay. So if they have families, for example, they could come back and find out that they're younger than their grandchildren. Now, that sounds like science fiction, but have already seen the baby step with the experiment that I'm talking about. And we actually see it even more dramatically. There's a device at CERN, Switzerland called the Large Hadron Collider. What they do is they smash subatomic particles together. When they do that smashing, they create other particles. Now, some of these particles can only live for a very, very short period of time and then completely disappear. But when they speed these particles up close to the speed of light, which they can do, they find out that the internal clock of these subatomic particles slow down to the point that they can get these particles to live 10, 20, 30 times longer than they normally can. So time slows down. Incidentally, one of the science fiction movies that gets it right was the original version of Planet of the Apes. They go out in space and
Mhm.
come back, and they think they've come back on another planet. But what happens is they actually come back into the Earth decades into the future when the Earth has been taken over by, apes. The taking over by apes, of course, is the science fiction part of it. But the real effect is that they were in a rocket that was traveling close to the speed of light. So for them on board, it didn't seem like much time was passing, but decades, centuries was passing here on the Earth. So time travel into the future is not only possible, but we have achieved it, but on a very small scale. As I said, we don't have objects can go rockets that can go close to the speed of light, but it is happening. So to answer your question,
So,
yes, your clock is slowed down, your heart rate slowed down.
so maybe we should all get on go to the moon a couple times to like live longer.
Well, in fact, those astronauts, that effect has happened more dramatically for them than it has for us.
So you talk about using light because we just discussed this, using light to manipulate time. Explain a little more about this.
Okay. Well, that's a different effect, okay, that we're
Okay.
talking about. Okay. The effect that I'm talking about, this first effect, in fact, this is called the special theory of relativity, which says that time is affected by speed, but you're not actually using light to do that. You're actually just using speed to do that. And I should mention that no matter how fast you can go into the future using speed, but you can't go back into the past. And that was one of the things that I was interested in was the possibility of going back into the past. So to summarize, Einstein's special theory of relativity says that time is affected by speed. Time slows down for speed. Einstein had developed a second theory that took him 10 years. He did develop this in 1915. And the reason why he did this had to do with the fact that he had to apply this to everything in the universe, including gravity. But according to Newton, gravity, nothing can affect time, including gravity. But in Einstein's theory, it turns out that gravity can actually, in Newton's theory, it appears as though gravity can actually travel faster than the speed of light. And Einstein said that can't happen. Nothing can travel faster than the speed of light, including gravity. So he actually developed a whole new theory of gravity. And he said that gravity, in fact, can affect time. Okay, the stronger gravity is, the more time slows down. What he meant by that is, for example, a clock here at the surface of the earth where gravity is strong, that clock is
Mhm.
actually running a little slower than a clock at a high altitude. Now, you might say, wait a minute, has that been shown? Not only has it been shown, but it's part of our everyday life. Once again, people don't realize this. It has to do with the GPS. The way the GPS system works is right now there are satellites orbiting the Earth. And these satellites, some of them are in geosynchronous orbits, which means they hover over one particular part of the Earth. These satellites send a signal. Your car has a GPS unit in it. The GPS unit has a clock associated with it. What happens is that the satellite is sending a signal at a certain time, which reaches the unit in your car at a certain time. Now, there's a very simple relationship in physics between distance, speed, and time. If you know any two of those, you can compute the other one. So if I know the time the signal was sent, the time it was received, and I know the speed of the signal, which is the speed of light, I can actually compute distance. And that's how the GPS system works. However, when they were setting up the system, it wasn't working. Okay. It was actually giving incorrect distances. You might say, well, why was that? Well, remember, I said, according to Newton, nothing can affect time. So when they were setting up their system, they assumed that the clock in your unit is running at exactly the same rate as the clock on board the satellite. But remember, according to Einstein, your clock in your unit, because it's closer to the surface of the earth, that clock is actually running a little slower than the clocks on board the satellites. Those clocks are actually running a little faster. So they have to use computers to take that into account. And when they did, the system was working perfectly. So that does show on a practical level that time is affected by gravity. And that's the beginning of where my work comes in. In Einstein's theory, and that particular effect is actually called the general theory of relativity. So the special theory of relativity says time is affected by speed. The general theory of relativity says time is affected by gravity. But it turns out that there's something else going on in Einstein's theory. And this is really revolutionary. In Newton's theory, the only thing that can create gravity is matter. The matter of the earth keeps us anchored on the earth, the gravity. The gravity of the sun keeps us in orbit around the sun. According to
Yeah.
Einstein, not only can matter create gravity, but light itself can create gravity. Now, this is an interesting point here. And this is where my work came in, because it turns out that gravity can affect time. We already established that. And as I
Yeah.
said, we know that on a practical basis. But now
Yes.
let's see the logic here. If gravity can affect time and light can create gravity, then light can affect time. And that's what my work is based on. I've been able
Okay.
to show, when I say show, I should mention that I'm a theoretical physicist. Einstein was a theoretical physicist. There's a division of labor in physics between what's known as experimental physics and theoretical physics. Theoretical physicists use equations to try to understand how the universe works. Experimental physicists use equipment to actually test how the universe works. Okay. And so Einstein came up with the equation that every school child knows, equals MC squared. That's a mathematical equation, but it
Yeah.
was experimenters who actually showed that you can convert
How
matter
to
into
convert it.
energy. So what I was able to do was I was able to say that there's a device, and this is a real device. It's called a ring laser. What is that? It's just simply a device that creates a laser beam that moves around in a loop.
Okay.
So you can do this by bouncing the light off the laser beams off the mirrors. And there's other ways you can do that. But that's all a ring laser is. A ring laser is a device to create a circulating beam of laser light. And what I did was I solved Einstein's gravitational equations for that. And what I was able to show is that normally time moves for all of us. Time goes, you can think of it as a straight line, okay, throughout our life. Let's say that I have a strip of paper here, and let's suppose that at the bottom of that strip is today. I mean, let's say yesterday. The bottom of the strip is yesterday. Let's say the middle of the strip is today. The top
Okay.
of the strip is tomorrow. Okay. So this strip of paper, I can go from the past to the present to the future. Okay. But now remember that time and space are connected to each other. That is to say, that strip of paper, in a sense, you might say, is embedded in space. Okay. Now, in Einstein's theory, this what I was able to show is that the circulating beam of laser light can
Yeah.
actually twist empty space itself. This is kind of a strange concept, but according to Einstein, space can be is is part of gravity, okay? And that by manipulating space, I can manipulate gravity. And what I was able to show was that by using a circulating beam of laser light, you can actually twist space around, and time is embedded in space. And so time can be twisted in a loop. So take that straight piece of paper that I was talking about, and let's say
Yeah.
we make a loop out of it. I can go now
Okay.
from the past to the present to the future, but I've made that strip of paper into a loop. So I can go
Can
from the
you go
past, present
backwards?
to the future. That's right. I can go back to the past. So by
Okay.
using a circulating beam of laser light, I can create a loop in time, and that along that loop in time, I can actually go back into the past. And this is, as I said, this is all based on Einstein's theory. And as I said, what I
Okay.
did was but that's the difference. What I did was I solved these equations. And so my solution shows that this is possible. The Now, in order to do this, you actually need equipment to do that. And that's where experimental physicists would come in. They would actually create the device based on my equations to show that this is possible. That hasn't been done yet. You might say, well, why? That's because just like everything else, money makes the world go around, and real scientific experiments are expensive. Let me just give you a very simple example. Remember I talked about this device called the Large Hadron Collider in Switzerland?
Yes.
All that does is it smashes these subatomic particles together. And you might say, "Now, how much is that going to cost?" That device costs $10 billion just to
Wow.
do that simple thing, just to show that space can be twisted. And I'm not even talking about the time portion of it, just to show that space can be twisted by a circulating beam of laser light. We're talking millions of dollars. Okay.
Yeah.
So that's where we're at right now, is trying to get the
Okay.
funding. And I don't ask the general public for the funding. I don't even want the general public. This is the kind of project that big
The government has to
financiers
do.
or foundations would be involved in. But that's something that we hope will happen in the future. But that's where things stand right now. We have the basic
So,
equations, but we haven't built the equipment yet.
so I want to change the topic to Back to the Future.
Right.
I'm sure you saw that,
Oh
and I'm
yeah.
sure you.
Yeah. It's one of my favorite movies. I've seen it many times.
Okay.
Yeah.
So in that movie is the grandfather paradox, which is if someone travels back in time and they prevented their grandparents from meeting, you would not exist. But you have an interesting theory relating to energy that would negate this paradox. Can you explain
Yeah.
that?
Well, the thing is that the thing that it's not actually my theory. It actually has to do with quantum theory. Remember what we've been talking about so far is the theory of relativity. Remember,
Okay.
I said that Einstein also made contributions to quantum theory. Relativity deals with space and time. Quantum theory deals with matter and energy. Quantum theory is what we need to understand how atoms work. That a periodic table that everyone sees in their chemistry class, that is based on quantum theory. So quantum theory tells us how the atom works. Quantum theory, if you think relativity is weird, quantum theory is just like off the charts as far as being strange is concerned. One of the things that quantum theory predicts is the fact that you cannot talk exactly about what happens next. In Newton's theory, if you have enough information now, you can predict how things are going to behave later. According to quantum theory, you can't do that exactly. In fact, there's a principle that's called the uncertainty principle. It says that you can never get enough information at any particular instant of time. And because of that, you can only talk about the probability of what's going to happen next. You can't talk about exactly what's going to happen next. That's a very strange aspect of quantum theory. And in fact, it gets stranger. It turns out that there was a physicist back in the 50s. His name was Hugh Everett III. And what he decided to do was not just apply quantum theory to the atom, but to the universe as a whole. And what he found was this, it made for a very, very strange prediction. Once again, this is mathematical, but what he predicted was that suppose that let's just use a simple example. Suppose that at dinner this evening, you went to a restaurant and you looked at the menu, and suppose there was two items on the menu. Item A, we'll call it, and item B. And let's suppose you said, well, I'm going to choose item B. So you choose item B. At that instant, what happens is that there's a split of the universe. There's a Carl who chooses item B, but there's also a separate universe that splits off in which there's a Carl who chooses item A. These are both real and separate universes. This theory was called the many universe theory. We now think of it more in terms of what's called parallel universe. So this means that for every single decision that you or anyone else makes, there's going to be a split in which you make that decision, but you make the other decision as well. So I think this could lead to an interesting philosophy of life if this particular aspect is true, because it would say that to me, no matter what it is that I do, in some universe, I got it right.
Yeah.
But that is part of quantum theory. This is actually real. And quantum theory we know is real because if we didn't have quantum theory, we wouldn't be cell phones, our personal computers, all of these things are based on quantum theory. It's just that it's hard to tell whether or not the parallel universe happens because you can't be in both universes. There's a separate you in either universe, but you can't talk to yourself in the other universe. Okay. Now, what does this have to do with time travel? Well, there's a physicist in Oxford University, David Deutsch is his name. And David Deutsch decided to look at what this implies if you're talking about time travel. He said, suppose that you go back into the past. At the moment that you arrive in the past, there will be a split of the universe. You would arrive in a parallel universe. Now, in that universe, you could prevent your grandparents from meeting each other. You would just find yourself in a weird universe in which you weren't born. But it's possible because there's no paradox there. You weren't born in that universe. However, remember I said that you arrive in the past, there's a split. The other path you don't arrive in. And in that other
Okay.
parallel universe, your grandparents meet each other and have you, and you were able to go back. So the essence of what David Deutsch found out was is that you can travel back to the past, but the past you arrive in is not the past that you came from. So
Yeah.
that essentially takes care of the paradox. There's no paradox if we bring quantum theory into the picture. Okay. So that's why this other
So
pillar of physics actually can take care of that paradox.
the idea of time travel is controversial. How do your colleagues react to your beliefs and passions around this idea?
Yeah. Well, the thing is that the reason why they believe that in the notion of it is not because it's Mallett's notion of the possibility. It's based on Einstein's theory. I wouldn't take it seriously. My work is based on Einstein's theories of relativity. So the question is that it's not even a question of, as I said, we have GPS and that works because time is affected by gravity. We actually know the subatomic particles in the Large Hadron Collider, they they shift in time because of the fact that the speed affects their lifetime. So these things are real. These things are, and they're all based on it. The question about traveling back into the past, however, is another matter altogether. Remember, I said that we haven't built equipment to actually show that twisting of space due to circulating beam of light. Okay. Now, the twisting of space eventually leads to the twisting of time. The energies that are involved with it, that's where a bit of the controversy comes in. Okay. And I actually have to agree with them. The energies that seem to be involved to do that, the twisting of time, are galactic. They're unbelievable. So, from a practical standpoint, it seems as though it would be very exceedingly difficult to try to do it on a practical. However, that's because, once again, quantum theory hasn't been taken into account. My work is based purely on relativity. I haven't taken into account quantum theory. I feel that once quantum theory is taken into it, and we don't have a quantum theory of gravity yet, that this may reduce the energy requirements. In fact, that's what happened with equals mc squared. Even Einstein wasn't sure whether that could be proven. We know that E equals mc squared works because of the Manhattan Project, for example. But once again, quantum theory was necessary to overcome the problems that would have been involved. Classically, we would not have been able to achieve what we were able to achieve as far as atomic energy is concerned. So for me privately, I feel that my work is based on Einstein's general theory of relativity, and that's fine. But as far as practical, the engineering part of it, that is something I feel is going to have to be looked at on the basis of quantum theory. And as I said, that's a
So,
critique that I actually agree with.
do you think there are time travelers amongst us?
No, Carl. The thing is that do I think there could be? There's two
Yeah.
different questions you're talking about there.
Yeah.
I should mention that, and this question comes up a lot. The thing is that time travel is possible, but you have to remember that you have to have some process that's creating these loops in time. So, for example, suppose I turn the device on today and I leave it on, let's say, for 10 years. Someone 10 years from now could send information back or in principle could come back, you know, 7 years, 5 years, all the way back to the time the machine was turned on. But you can't go back earlier than that because the machine wasn't turned on earlier. It's the device that's turning on, and it doesn't matter what we're talking about. Rotating black holes, by the way, which is part of Einstein's theory. There's a prediction that says that a rotating black hole can actually create these loops in time, but you the loops in time, even for a rotating black hole, can only be created after you have the rotating black hole. Before the rotating black hole, you don't have a process that's going to create it. So
Yeah.
this doesn't have to do with any particular terrestrial device. Any process that's going to allow you to create loops in time will create the loops in time after the device is turned on. So I'm a big fan of science fiction movies, for instance, but you can't have Terminator is a good example. You just can't have Schwarzenegger appear out of nowhere. There has to be a device. In fact, what I tell people is that if someone comes up to you and says, I have a time machine and I've just arrived from the future, I say, first of all, be polite with them. Okay. All right. Second, say, "Oh, that's interesting. Show me your device." And what they'll do is call it the blue dragon effect. What that is, someone says that they have a blue dragon, and you say, "Okay, show it to me." They take you to their garage and they say, "Let me go in." They say, "Oh, he's sleeping. The dragon's sleeping." Say, "We're gonna," and you go back and you say, "Oh, they're sick." And so, in other words, you're gonna find that no matter what you ask, they're never going to be able to show you the device because you can't have materialized out of nothing. There has to be a device. So that to me is the thing, the test. Science is a verifiable subject. It's not something that you can, I mean, for instance, my work, the equations that I have, there's a book that I have that's been translated in a number of different languages, and it's not technical, but it has it has a very simple piece of the equation that I have developed, and that equation looks exactly the same in the Chinese version, in the Japanese version, and the Korean
Yeah.
version. What that means is independent of Mallett. Any scientist anywhere can verify it. And that's important in science. So if someone says that they've traveled back in time, don't believe it unless they can
Yeah.
verify it. Okay.
That's what a scientist does, right? We need verification.
Exactly. That's
Yes.
the hallmark of science.
Yeah.
That's exactly right, Carl.
Yeah.
Is verification, and so that's important. So to me, time travelers, terrestrial time travelers, in any case, no, because a terrestrial
It,
time machine has been invented. But remember, I said terrestrial. It turns out that scientists now believe that there's, we believe it wasn't until the 1990s that we actually were able to verify that there were what are known as extrasolar planets. What that meant is that besides our sun, where we orbit around it, we now know that there are other solar systems out there that have their
yeah.
own planets revolving
Yes.
around them. Okay. And so we know that the probability of life, that the life is probably, the universe is probably teeming with life. We may not
Yeah.
have the question of whether or not they've seen us. That's a different question. But I believe, and scientists generally believe, that there is life out there. The question is that some of these planets, if they have life, may have been developed, their technology to the point that they have developed time machines
Yeah.
already and had them
Yes.
turned on. They would have the same limitations. But let's suppose that they have developed their device and turned it on 10,000 years ago. If we find them, or if they come back to us, they could probably come back to our ancient past. Okay. But that's once again something that would have to be verified. So, in principle, extraterrestrial life may be able to have traveled back to us, maybe. But once again, that has to be verified. But as far as terrestrial time machines, yet we haven't developed the technology in order to do that. Eventually, we will. And I think, to me, people have said, well, what would be the other importance of having time travel? Well, think about this. Carl. Imagine that we have this, and imagine that we had already had this turned on. Imagine having been able to send our information, medical information, back to ourselves about COVID before it even began,
Yeah.
sending information about tsunamis, earthquakes, hurricanes. Think of the thousands of lives, millions of lives we could potentially save by having that. But to me, just the possibility that this could happen, to me, is worth, investigating the possibility, because having control of time, that would give us a control of our destiny that we can only dream about. But to me, the fact that human beings dream about these things, I really do believe whatever the human race dreams, it can achieve. It just isn't going to be simple. Just like Jules Verne came up with the notion that we could travel to the moon, but the technology and the science and everything that's going like that, it's a huge difference between the dream and the reality. But first, you have to have the dream and you have to have the scientific knowledge. And we do have the basis for it. Einstein's theories of relativity.
So as we start to wrap up here, I can start where we began, talking about your father. Your father led you on this fascinating life because you were trying so hard to connect to him. And it's really interesting to me to see like how your father's still with you today.
Absolutely, Carl. And one other thing that I really would like to mention, because it's important as part of my life. You mentioned, thank you for mentioning my book,
Yeah.
Time Traveler. But one thing that's happened very recently that I'm very excited about is that there's a producer. His name is Tom Brittany. He's also a major actor in the UK who's become interested in my book. And there's an US director, Josh Green. They both become interested in adapting my book as a feature film, a Hollywood feature film. And so that's had processes begun. So that's something that I'm very, very excited about. And I just wanted to mention that. Keep your eyes out because that's something on the horizon.
This is so fascinating. Dr. Ronald Lawrence Mallett, thank you so much for joining me. The book that we were just talking about is Time Traveler: Scientist's Personal Mission to Make Time Travel a Reality. Let me know what you thought. Put your comments in the section below. And until next time, everyone, be safe.
Thank you.